Good day, everyone. I will discuss to you the lesson 2 for module 6. So this is all about the logarithmic functions. So in this lesson, we are going to talk 7 topics. The first one is the definition of logarithmic functions. Second, evaluating logarithmic functions. Third, properties of logarithms. Then I will going to teach you on how to expand or condense logarithmic expression, and then we are going to solve also logarithmic and exponential functions simultaneously, and then finally, of course, we are going to tackle real-life applications of logarithmic functions. So let's start with the definition of logarithmic functions, but before that, let's talk about the history first of the logarithmic function, or the history of logarithm. So nganong may exist maning logarithm, unsa may purpose ani? Now, in early days mong good, wala sila yung mga powerful calculator. So no powerful calculator or even simple calculator nga device. So wala sila powerful nga calculator. So what they did is they devise, or they create a certain table. So nasa like table are, himo sila ng table, so ilagay ning i-calculate manually. So nasa like table of values. And what are these values? This is known as the logarithmic table of values. So logarithmic table of values. Ano sa purpose na ini? Of values. Okay. Now the purpose of this is to have an equivalent logarithmic number for a certain real numbers. Kay sa una magod, let's say if you are going to multiply larger numbers, let's say we have 1, 4, 3, 2, 1, 2 multiplied by 217 and 5, 3, 4. Now, if you're going to solve it manually, kay wala may calculator sa una, so lisod kay di man siya lisod, but it will take a lot of time. So they decided to use the logarithmic tables, and not only for whole numbers class. Ang lisod po ka mag-multiply if unsa man nana kay mga decimal point. So suppose we have here an example. We're going to multiply these two decimal numbers, 14.23 and okay, say erase 14.23 and 17.97. So kani siya, although as a whole number, two decimal places siya, ones and tens, but since ang siya kanang decimal, so if we're going to multiply it manually, so kuan siya kanang daghanan ni, because the entire thing is composed of 1, 2, 3, 4 decimal, 4 digits na. So ang resulting ani, ang product is 255.7131. Now, if you're going to solve it manually, taas kaayo, and then there's a possibility nga magka-error ka during the process. Now, what they did, they used this logarithmic table of values. So, kaning 14.23 or each real numbers, they represent this one as in an exponential form. So, ang kaning every number can be written as 10. So, a 10 lang gamit, base 10, or you can have base e, katatong natural numbers, remember, or you can also base that one by using the number 2 or 3 or 4. So, sa ilaha, base 10 sila. And then, this 14.23 is just equivalent to 10 raised to the power of 1.1532. So, iya power kay naka-decimal kuan pod, naka-decimal form pod. Kung yung ato na-simplify, mo-equate po niya sa 14.23. And then for 17.97, it is also equivalent to 10 raised to 1.2536. So, na siya gamay nga gamay nga difference sa value, pero kung mo siya i-round up to this, two significant digits, then equal sila. So ang kani siya kaning exponent, so kaning exponent mo siya gitawag nga logarithmic values. So logarithmic values, and then you can find it in the table. So ang ilang gibuhat is that, diba, if you're going to multiply two numbers with the same base, diba, the rule of exponents, the law, kay bar man sa law sa una, so that would just be equal to 10 raised to 1.1532 plus 1.2536. And then if you're going to simplify that one, you just add the exponent, so that would equal to 2.4068. Now natay bago na pud nga logarithmic values, diba? Logarithmic values ni siya. And then in order to get the final answer gid niini, ilahang gigamit ni nga logarithmic values, ang resulting logarithmic value or the resulting exponent, ilan siyang ngadto gipangita sa logarithmic table. And then after nila nga nakita nila sa logarithmic table, then ilang tay kuan kung unsay corresponding pud nga number, and then by having the interpolation, then they can get 255.7131, which is similar gid, although na ay gagmay nga discrepancy sa kuan decimal places, pero yung siya round off, then you get the same answer sa imuhang pag-solve using the manual nga multiplication. So kana siya dali na siya. Why? Because you just locate this logarithmic value sa table, and then you can easily look for the answer. And yeah, mas accurate siya since kaning table of values na naman siya daan, gihimo naman siya sa mga scientists pud sa una, or mathematicians mathematician. So mas easy na ang life. So mo na siya tungod kay walay calculator sa una, na-encourage yun ang mga tao sa una nga gamiton ning logarithmic table of values. So there may arise ang logarithm nga kuan nga kanang idea. So after this history, atong kanon kung unsa dining logarithmic function. So importante kay logarithmic function, no? So for a logarithmic function class, again, it is represented by this notation. F of x, or simply our dependent variable y, is just equal to the log. So mo na siya log of x to the base a. So ato sa i-identify ang mga parts. Now kani mo na siya atong base. Okay, that's why we read this as the log of x to the base a. So mo na siya ang base. So remember, kani siya ang logarithm kana sila i-relationship sa exponential. Now ako isulti ninyo nga ang logarithm is just the inverse of the exponential function. So ato na siya i-prove niya. Okay, unsa po ni siyang x ari? Ang x is our resulting number, or the number itself. And then how about this one? Now this is our dependent variable, or we can call this one as the exponent. So one siya. Again, this one is our base, this is our number, and then our dependent variable is the exponent. Now this notation would only exist if and only if mo exist pod ang iyahang equivalent nga exponential form nga x is equal to a raised to y. Okay, kani ato siya gi-convert para ma-visualize ninyo nganong gi-called ni siya nga base, nganong kaning number, kani pod ang atong dependent variable exponent. Because if you're going to transform this into exponential form, na ato na nakita diri, di ba? Ang x is the number, the resulting number. And then kita diri ang a nahimo ng base, and then c ang y nahimo na exponent. So kung makita mo ging aning notation, kakita kay mo logarithm, again ang answer sa logarithm is the exponent, kay di ba? Log of a number with the base a is equals to blank. So that would be the exponent. And then a kaning nabutang sa ubos sa log mo gina ang base nimo, and then the log of something mo na siya nag-indicate nga nag-indicate na siya sa number. Okay, So again, in the logarithm na po tayo restriction yani. So the same with the exponential na tayo restriction. So na tayo restriction ani, wherein a should be greater than 0. Why? Because take a look at this, diba? If mag less than ganing a, what would happen? Now, ma-imaginary siya kung ang ato exponent mag-even fraction. So, dapat a greater than 1, greater than 0. What else? A should not be equal to 1. Why? Because we cannot create an exponential function kay ma-create na taog kanang line. And then, kaning logarithmic function class, mayroon ko ninyo ganyan is the inverse of exponential. Ato kitaon nga nang inverse mo niya sa exponential function. Okay, again, take note, mo ni ang mga parts ha. Mo ni ang parts sa logarithmic function, and then naapod siya equivalent nga exponential form. So ato gipakita nga mao na yung base ni siya, mao pong exponent ni siya, since kay kung ito transform, mao po na iyahang kanang forma. And then don't forget the restriction, say a should be greater than 0 and a should not be equal to 1. So maingon mo ta naman tay claim ganiha nga si logarithmic function daw is just the inverse of the exponential function. Nga naman nga nung inverse mo na siya, because logarithmic function is a 1 to 1 function. Kasi pasabot ani, meaning one value, for every value or for every domain sa ato ang function, mo correspond na siya og one value pud sa ato ang sa atong range or sa ato ang dependent variable. And then we can visualize this one-to-one nga relationship by having the inverse principle of the logarithmic function and the exponential. So magamit ato ang inverse of a function. So inverse of a function in order to prove this claim nga one-to-one ni siya nga function kaning logarithmic og exponential function. Now, diba, just a review, ang ato ang exponential function, so muna siya exponential function. Exponential. Diba, remember, exponential function is denoted with this. F of x is equal to a raised to x. Ingon man ta nga ang inverse sa exponential is logarithmic function. Now, let's solve for the inverse. So, take the inverse of this. So, unsa kay inverse ni ini? So, in denoting the inverse class, we use f of negative x, meaning mo na siya ang atong inverse. Now, just a review sa ato ang a discussion about the inverse. Now, if we're going to take the inverse of a function, you just replace our independent variable sa dependent variable. So, replace x by y, and of course replace x by y, and then y by x, anara by luhon na siya. So therefore, from this function, ang f of x may mo na siya og x. Okay, ang f of x, y ba na siya, and then a raised to the power of si x diri, since ato man gi-interchange sila or gi-replace, may mo na siyang y. Now, nabali na siya. So what we need to do here, we apply the logarithm of kanang both sides. Or remember sa previous na to nga, diba? This is just simply sama na siya. This is just simply equal to the logarithmic function, diba? Logarithmic function na siya. Logarithmic function is siya notation katawang gingan ganiha. Kay diba? Y is our exponent, right? Kana siya, mao na ang exponent, mao na niya atong base, then mao na yung number. So diba, since ang ato na magong dependent variable kay na siya sa exponent, so therefore it is now in a logarithmic form. So therefore we can say that y is equal to, again, log of the number, ang atong number diri kay si x, with the base of a. So therefore ang inverse di ay, so f of negative 1 of x is just equal to the log of x to the base a. So see, naata exponential function, ang iyang inverse kay nahimo na og logarithmic function. So logarithmic function. Now, kung sa may kuha na to evidence nga inverse gyud sila. Now, para makuha na to nga inverse gyud sila, mag-substitute ta. Kay naaman sa nasa theorem nga if imo siyang i-substitute, let's say sa exponential, okay, sa exponential gali class, diba it is represented by f of x is equal to a raised to x. Now, ang imong value sa x, kung imo na siya i-replace by the f1 of x, or this is known as the composition, diba? Ang operation sa atong function, composition. Now, applying the composition yung operation, katong f contains g of x, diba? Nga na to siya. But here, ang atong kanan is f contains of the inverse. So, mag-denote nato siya as f contains the f negative 1, diba? Of x is equal to, we don't know, or blank. So, therefore, ang kaning entire thing the entire thing f of negative 1, mo na siya ito isud sa x. Kaya, diba? Mo na ang procedure sa composition nga operation sa function. So, in order to do that, that would be equal to f contains f of negative 1 of x is equal to a x. Now, ato na siya i-substitute. So, that would be equal to a. Unsa man ang unsa man ang f negative 1, that's just equal to log of a to the x. So, that would be log of x to the base a. So, mo na siya ang answer for kanang kuan. Mo na siya ang answer for the exponential nga side. And then, by applying the properties of kanang kuan, exponential function pod, kanay siya, this is just equivalent to, unsa man? This is just equivalent to x. Kaya ato na siya makuan, ma-discuss ni siya nato further sa properties sa logarithm. Unya. Okay. Now, para ma-prove na to nga kuan gini sila, inverse gini sila, dapat it must be that f contains f negative 1 of x must be equal pod sa kung si f na pod ma-contain sa inverse nga negative 1. So equal pod siya sa kung si f of negative 1 si f ma-contain na pod sa f of negative 1. So nga na siya. So here, human na ta sa f of negative 1. Wala pa ta sa f of negative 1 contains f. So kana gud nga side is sa logarithmic na siya nga side. So logarithmic nga side. Logarithmic function nga side. So in the logarithmic function nga side, we are given f of negative 1, di ba? Kay inverse man siya. Is equal to log of x to the base a. So here, mo-apply ta sa composition. So applying composition nga operation, so we have now f of negative 1 contains f of x is equals to blank. So here we can denote this as f of negative 1 contains f of x. So meaning the value of the independent variable for the f of negative 1 is equal to the entire f of x. So this would be equal to log of x to the base a. So substituting unsa man ang f of x, di ba? Ang f of x is just equal to a raised to the power of x. So that would be equal to log of a to the power of x with the base a. So di ba? Yan na siya. And then unsa maning log of a to the power of x with to the base of a, unsa man na siya? So unsa man na? Equal po na siya sa unsa man? Equal po na siya sa x. This one is equal to x. Now ato na siya ma-prove by applying the properties of kanang logarithm. So diri properties of exponential, kani siya properties of logarithm. So ato na siya i-discuss later on. So therefore, since same man sila, duha man, I mean, ang ila answer for both compositions is equal to x. So therefore, we can say that both of them are I mean, na ay one-to-one nga relationship na exist, and then we can say that the logarithmic function is the inverse of the exponential function and vice versa. Now, unsay itsura man sa ilahang sa ilahang graph for both, since inverse mo kasi ya. So again, recall sa inverse nga ang pag-graph sa mga inverse function. So here natay Cartesian coordinate system. This is our y and this is our x. So diba kaiba naman ta sa graph sa exponential. So ato na i-represent sa blue nga color here. So ay exponential kay asymptotic siya with respect to the x-axis, and then it will increase rapidly until positive infinity. And then sa logarithmic function good class, I mean sa exponential natay gitawag nga kani siya exponential, natay gitawag diri nga rapid change. Rapid change. Kusog paspas kaayo ang mga values. Bisag at small amount of, I mean small values for x, kusog na kay pagtubo. Whereas sa logarithmic function class, inverse siya. So asymptotic siya sa 0, meaning dili pwede nga ang y mahimong 0. So ana na siya, asymptotic siya sa y-axis, and then mo increase siya pahinay sa x-axis. I mean increase siya pahinay until positive infinity. So as you can see right here, ang iha kay small increase or small nga change. Again, for this one is exponential. Kusog kay ang pag-change sa values, whereas for the logarithmic, small ra ang pag-change sa values. So logarithmic function. Now, unsa man to ang ato nakuha ganiha nga x. So kani ato nakuha, since both of them are equal, ato na siya ma-represent ang line nga asa sila symmetric. So mo nang natay y is equals to x. So kani siya nga linya, mo na siya reflection sa ato ang logarithmic o exponential function. Kunya kani siya gidenote ni siya sa kanang ang iyahang function is denoted by y is equals to x, or f of x is equal to x. So mo na atong nakuha ganiha, di ba? Nag-take ta og composition ganiha, then we arrive this f contains negative 1 of x, or y is equals to x. Same po sa logarithmic, f negative 1 contains f of x, which is the dependent variable is equals to x. So mo na siya, pag plot nato, dira midway siya between exponential and logarithmic functions. So mao na siya ang ang proof nganong gitawag ang logarithmic function as the inverse of the exponential, and then why it is also called as a one-to-one function. So again, mao na siya ang itsura sa graph. So let's proceed now to the evaluation of logarithmic functions, or how are we going to evaluate logarithmic functions kung hatagan ta. So here, when we say evaluation, we have some values for our x. So let's try our first example. So let's say if you're given f of x is equal to, again, log of the number x with the base 2, such that your value of x is equals to 16. So here, kung na may calculator, you just plug in log of 16 to the base 2. That is equal to, sama na siya. So may equivalent anang log of 16 to the base 2. Now, kung na may calculator, plug in nimo, ngadto ka, naman na siya logarithmic function. So log of 16 to the base of 2 equal to 4. So equal siya sa 4. Now, to prove this, di ba? Unsa ra gud toy another equivalent ni ining logarithmic function, di ba? In terms of exponential form, kana siya is just equal to x is equals to 2 raised to y. Diba again? Ang dependent variable the f of x is the exponent of the logarithmic function. And then x here is the number. 2 here is the base. Muna akong gipresent siya ini. Now, kung ato na siyang i-substitute ang x diri nga value, so this would be equal to 16 equal to 2 raised to y. Magipangita si y. Now, what we need to do here is, again, take the logarithmic of both sides, or we can also change this one, diba? Sa ato ang kanang discussion sa exponential, diba? Katong nakainamdom pa mo, in order to solve for exponential equations, diba? You must have a to the u, which is equal to a to the v. If the base of both sides of the equation are already the same, so therefore we can equate their exponents. That is u is equals to v na. Okay, so here, di ba ang 16 ma-reduce man na siya into into a small prime number, small prime factors of 2. Okay, 16 may mo siyang 2 raised to 2 times 2 is 4, times 2 is 8, times 2 is 16. So that is 4. Diba? 8 times 2, 4 times 2, 8 times 2, 16. So that is 4. So 2 raised to the 4 is equal to 2 raised to y. Since same naman sila ang base, diba? They already have the same base. So therefore, we can say that y is equals to 4, or we just simply equate their exponents. So therefore, maunang ko imo i-plug in sa calculator, makakuha ka og f of x equals to 4 for log of x to the base 2. So let's try again another example para ma-practice ta. Let's say you are given f of x is equal to log of the number x to the base na pod of 3, such that our x here is equals to 1 over 9. So 1 over 9 na siya. Now, if you're going to substitute this, if you have calculator, so log of 1 over 9 to the base of 3 is equal to, so I'm gonna plug in sa calculator, log of 1 over 9 to the base of 3 pala, that is 3, is equal to negative 2. So again, ang answer good sa logarithmic function is the exponent, so that is negative 2. Okay, so, or atong y or f of x equals to negative 2. Now, ato i-verify by solving this ayang exponential form nga counterpart. So kana siya can be written as the number x is equal to the exponential form 3 ang base raised to the f of x or y. So here, atong x is 1 over 9. Substitute that is 1 over 9 is equals to 3 raised to y. So remember again, from this principle, ito na-apply ara. So since si 9 kay kuan man siya, napa sa denominator. So para mautang-tang ang fraction, what we need to do is ato na siya i-butang sa numerator. So kung ato na siya i-butang sa numerator, ay ang exponent nga 1 mahimong negative 1. So that is 9 raised to negative 1 is equals to 3 raised to y. So applying the principle aning a raised to u equals to a raised to v. So ato ang i-transform ni si 9 into a factor of small prime numbers, or not small prime numbers, mga prime numbers yun siya. Okay, ang 9 can be factor as 3 squared, di ba? 3 squared is equals to 9 is to negative 1 is equals to 3 raised to y. So di ba, same na sila og base. So kani siya by power rule, multiply na to ang exponent, so that would be 3 raised to negative 2 is equals to 3 raised to y. Since they have the same base, so we can equate their exponent. That is simply y is equals to negative 2. Ano na siya? And then, na-prove na to nga the same siya sa atong answer sa atong calculator. So let's try another one. Let's try another example. So we have here the third example. We have f of x is equal to log of x to the base of 5, such that the value of our x here is equal to 125. So again, using calculator, just plug in log of 125 to the base of 5. That is just equal to, so log of 125 to the base of 5. that is equal to 3. So therefore again ang answer ani kay ang exponent sa number nato nga x. So y is equals to 3. Now in order to verify that one by using the exponential notation, that is x is equals to the base 5 raised to the independent variable y. X is 125, so 125 is equals to 5 raised to y. Again, applying the principle a to the u is equals to a to the v, so dapat same ang base sa both sides of the equation. Now 125 can be written as 5 times 5 times 5 kay mo resolve siya og 125. So therefore that is 5 cubed. So 5 cubed is just equal to 125 is to 5 raised to y. So therefore, the same na ilang base, ni agree na tani nga principle, we can say that their exponents are equivalent. So y is equals to 3. So same ra gyud sa ato ang nakuha sa if magamit ta og calculator. So let's jump na sa last example. So last nga example, we have here f of x is equal to f of x is equals to log of x to the base of 4, such that the value of our x here is equal to 2. So here substitute directly, so log of 2 to the base of 4, the answer is, now plug this one in your calculator. So 2, that is equal to 1/2. So ang exponent sa atong number nga x is equal to 1/2. Now in exponential notation, that is the number x is equal to the base 4 raised to the dependent variable y. X is equals to 2 is equals to 4 raised to y. Now here, si 4 na pod ang kuan. Si 4 na pod ang kanang mas bigger kaysa ito, because on the left side si 2 kay small prime number naman gini siya. So therefore si 4 ang ato ang i-change so that we can achieve a raised to u equals a raised to v, and then equate their exponents directly or easily. So here we can see that 2 is equals to ang 4 can be written as 2 squared, diba? Product of small prime numbers. So 2 is equals to 2 raised to 2y. Multiply na nato ang power rules exponents. So since same naman sila base, so we can just equate their exponents. So si 2 din na invisible nga 1 nga exponent. So that is 1 is equals to 2y. Divide both sides by 2. We say that y is equals to 1/2. So kani siya ato na na-prove sa ato apod nga kanang method nga nagamit ta og calculator. So humantan ani sa pag-evaluate, now ato na pod additional knowledge is that dapat kay bawo po ta mag-convert sa exponential form into logarithmic form. Let's say naatay exponential form ani. So kani siya exponential form ni siya. Exponential form kani siya is logarithmic form. So saon pag pag-convert. Okay, let's say we are given an exponential form of 3 cubed is equals to 27. Now, unsa may equivalent ana sa logarithmic form? Again, unsa gani siya? This is our base. This is our exponent. And this is the number, right? The resulting number. So, unsa gay notation sa logarithmic form? That is just the exponent y is equals to the base, the exponent y is equals to log, so log of the number, so that is, let's say, x with the base of a. So ano siya? Again, ang resulting answer sa logarithm is the exponent. So here, kung sa mato exponent sa ato example, that is 3. So what nimo 3 is equal to the log of the number. Unsa may resulting number, that is 27. So that is log of 27, ang base nato kay 3 to the base of 3. So mo na siya ang equivalent niya in logarithmic form. Let's try another one. We have here 100 raised to 1/2 is equal to 10. So for number 2, unsa man ang ato ang exponent ari, that is 1/2. So mo na siya nag-serve nga kuan logarithmic value. So as 1/2 is equal to the logarithm of the resulting answer is 10 to the base of 100. So mana siya. And then the third one, how about if you're given this one, 2 raised to the power of x is equal to 9.1896. So kato siya i-convert again unsa exponent si x. So that would be x is equal to the log of what is the resulting number, that is 9.1896. Unsa may base atong exponential term, that is 2. So therefore mo na siya equivalent sa logarithmic form. So we have the last example. So we have x raised to the power of 4. So that is x raised to the power of 4 is equal to 90. So pag convert na niya, equivalent na siya sa exponent. 4 is equal to the log of the number, so that is 90 to the base of x. So basically, ingon ana pag convert from exponential to logarithmic form. And then the same thing na pud class sa logarithmic to exponential. Meaning kani ato na i-do the reverse. So 3 would serve as the exponent, that is 3, and then the base would serve as the base pod, so that is 3, and then 27 here would serve as the number, that is equal to 27. So again, for exponential form, the resulting is the number, or the result or the outcome is the number, while in logarithmic form, the outcome is the exponent. Marsha, exponential form, outcome is the number. Logarithmic form, the result or the outcome is the exponent. So let's proceed na sa properties of logarithms. Muna siya ang importante. Now class, before jumping in this topic, I will tell you the three types or three notations sa logarithmic function per class. Ang una is muna siya gitawag nga common logarithm. So common logarithm. So common logarithm, and then ang ihang kuan ani class, ayang notation ani is moto siya, let's say if we have y is equals to log of the number to the base of a, or any number ni siya nga base, mo siya ang common logarithm. Napatay gitawag nga common logarithm of base 10. So kato siya i-write into a function that is y is equal to the log of the number x to the base of 10, or sa atong calculator, kung yun na nabantayan, kung ang base na to kay 10, di-crush ato na siya. Marabag sa square root ba? Diba ang square root, kaya dinata mo right of square root of 2? Diba dinata mag-right of square root of 2? Okay, so diba as you can remember, ang square root of 2 is, ang index niya, no need na nga i-write ni ang number 2. Tungod kay automatic nga ang square root, ang index is 2. So same ra pod sa log of a number with the base 10. So ang 10 nato, di na nato isuwat dira sa kanang subscript. So ang kaning log of x, number or variable x with the base 10, kay isulat na nato as log of simply log of x na lang. So you are not going to include anymore, or you are not going to write anymore this base number 10. So man siya, and then I think makita na ninyo sa kuan sa calculator na anay log niya. Naman ito yung log of this, and then napoy log of a number, then mag-input po ka og base. So kani base 10 siya, kani siya kay any base number. So man siya sa common nga logarithm. So duhata natay log of a number with the base of any number aside from 10, and then we also have log of a number with the base 10. Gamit mo gud ang base 10, why? Because diba naman tay mga power of 10, like 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1,000, so on and so forth. And then katawang gisyo ninyo ganiha katong sa logarithmic table of values, diba? We can represent a certain number by an exponential number of the base 10, diba? Mas easy siya kaya naman siya generic na logarithmic table. So ay kaduha nga style sa pagsuwat or type sa pagsuwat sa logarithm kay natay gitawag nga natural logarithm. So natural logarithm. So ang iyahang pag-denote is y is equal to the natural logarithm ln. So andiri kay log, log logarithm. Ang sa natural kay ln. So ang ubanan ni gi-shortcut og basa as ln. Ln of x, number x to the base what na. Kay ngano? Kuming kag natural logarithm, ang iyahang equivalent ana in common logarithm, di ba kay ln, wala kay butang-butang areha nga ln of x to the base a, wala na. Ang natural logarithm, ang base ana niya is equal to, sama, the base is equal to e, the Euler number. Diri, marabag same sa common logarithm of the base 10. Ang base niya is 10. Sa natural logarithm, ang base niya kay e. So, kato na siya isuwat in the form of common logarithm that is just equal to the log of x to the base of e. So, para mas malahi po siya forma, ln na lang. So, again, automatic, ang ln, ang base niya kay e. So pwede ka makasuwat, ln of x, ln of 2, ln of any number. So, ingon, ana siya, ang sa natural logarithm. Let's say this is ln of 3. So, mara na siya. Again, equivalent na siya sa log of 3 to the base of e. Yan ara. Again, naatay common logarithm o nabutay natural logarithm. So, ato na siya ma-apply po sa properties. So, duha ato ang table ani sa atong kanang properties, ang common logarithm o ang natural logarithm. So, suwat ta ang sa left side kay ang common logarithm. So, common nga logarithm. Then, sa right side kay ang natural logarithm. Natural logarithm. Or ln. So, ln na siya, ln. Nya ka na siya kay log. This one is log. Okay, ang pinakauna nga property class, the first property is kani siya, log of 1. So, log of 1 or the logarithm of number 1 to the base of any number a is equal to 0. Why? If we are going to prove this in the exponential form, di ba? This is just equal to the base a. Nya unsa gyud toy result sa logarithm, that is the exponent. So 0 is equal to, di ba? Any number raised to 0, the answer is 1. So therefore, mana yung first nga property. Now, applying it on the natural logarithm with the base e, so that is just the ln daw of 1 is equal to 0. Why? Because e, so e na diri ha, ang base niya kay e raised to 0 is equals to 1. How about the second? The second property says that the logarithm daw of a number a to the base of a similar number a gihapon is equal to 1 daw. Why? Because if we're going to change it in the exponential form, again, unsa ang resulting number, that would serve as the exponent. So, our base here is a, then ang resulting number sa logarithm is the exponent. So, a raised to 1 is equals to the resulting number a. So, that is a. So, diba? Now, in natural logarithm, that is just the ln of e is equals to 1. So, dito mean nga ln of a. Kaya ang diri, meaning daw kuno, the resulting number here, the resulting number is equal to the base. So, since ang base sa natural logarithm kay e, so dapat ang resulting number is equals to e. Kay diri unsa man ang atong base, di ba? Ang base kay always e man for natural logarithm. Then raised to, ang answer sa ln is the exponent. So, that is
e raised to 1 is equals to the number e. Equals to e. Sana ra. Ikatulo, so kani magamit ninyo while during mag-solve mo or mag-simplify mo mga logarithmic functions or equations or expressions. So for number 3, we have here the logarithm of a raised to the power of exponent x to the base of a, that is just equal to x. Nga naman class, again, atong unahon pagsuwat ang base. So unsa may base ari, that is a. So unahan tog sa atong base a. And then unsay sunod isuwat? Sunod nato isuwat ang exponent, di ba? Ang answer sa logarithm is the exponent of that base, so that is x is equal to the resulting number. Unsa may resulting number? That is kani a to the a raised to x. So di ba equal naman ni siyang duha. Or ma-prove po na siya class by using this identity, that is a ganiha sa atong inverse function nga discussion, a raised to log of x to the base a, so meaning is equals to x. Diba gi-raise daw nimo ang number sa iyang equivalent nga logarithmic exponent. So diba ang number gi-raise siya into its equivalent logarithmic exponent. Now, kung ato na siya i-simplify by kanang class by taking the logarithm of both sides. So, let's say this is the log of this side and also the log of the other side para matangtang ang exponent. So, mano siyang procedure sa pag-eliminate sa exponent class. That is the log of x. So, kanisiya, kanang exponent mabalin ni siya sa iatapad. So that would be log of x to the base a multiplied by the log of a. Ito nakita pa rin is equals to the log of x. So divide both sides by log of a. Divide both sides by log of a. So we now have log of ax is equals to the log of x all over log of a. So basically, kani siyang property is the change of base. So ato na siya i-discuss later on. Change of base. Wherein ang kaning siya is just simply equal to the log of x to the base a. So mamaya, mao pa din ang other kanang way to prove aning third property. Now, katan siya i-apply sa loan, that is loan of e to the power of x is equals to the x, because we know that the base here is e raised to the resulting exponent x is equal to the number e to the x. So, ato na i-crash out. Let's try the fourth property. So, ato sa i-erase na sila. And the same thing with the loan. So, kanin siyang loan nga part, importante po ni kay daghang ba yung mga problems nga gamit nila kay natural logarithm. So, the fourth property natay log of y to the base a is equal to log of x to the base a. So, kanat siya, equivalent na siya tungod kay ang ilahang resulting number x is equal to y. Kaya nga naman, equal man ang resulting number because x can be represented as a raised to the power of exponent n, which is equal to ang y, since the same sila og base. So a, of course, automatic, di ba pwede dira mag-m. Nga naman, because kung mag-m ka dira, meaning lahi sila exponents, so therefore we cannot say that x equals to y because x is already equivalent to a raised to n, and then si y pod equivalent pod siya sa a. So it should follow that ang iya pod corresponding exponent would be equal to the exponent of x n. Kay para same as lag base, we can say that their exponent are also equal. Now, if they have the same base, automatic class, ang ilang exponent kay the same, unya ang ilahang ang ilang resulting kanang class number could be could either be kanang different sila. or I mean it's not different kundi the same, so therefore x is equals to y. So the same ang resulting number here. Mano siya ang kuan ika-fourth nga property in the kuan natural logarithm nga side, that is ln of e to the x, I mean ln of x pala, sorry, ln of x. Okay, ang base ani kay a man, so that is ln of x is equal to ln of y. Tungod kay, or it follows that x is equals to y. So same man ilaha base. Now let's jump to the fifth property. The fifth property kay gitawag na siya multiplication property. That is log of x and y. So gi-multiply nato ang resulting number to the base a is just equal to the log of x to the base a plus the log of y to the base a. So unsay pasabot ni class? Meaning ang exponent sa tagsa ka mga resulting numbers, di ba? Namatay first number nga x, second number y. Kung imo na siya i-multiply class, that is just ang resulting nila nga exponent, di ba? Ang resulting sa logarithm kay exponent. Ang resulting lang exponent is just the exponent for x plus the exponent for y. So unsa man nato pag prove class? So maglet ha. Let's say ang x is equal to base a, since di ba base man nila diri kay a, then raised to a certain exponent, let's say n lang, and then we also have another y is equals to a raised to m. So lahi sila mga exponents, ang ilang naka equal sila sa base. So we can say class that the product of x and y is just equal to the product both of their exponential form. So that is a raised to n multiplied by a raised to m. And then simplifying this, since they have the same base, so that would be a is equal to n plus m. So isum up ran ilang mga exponent. Now, ato na siya i-apply sa ato ang kanang kuan property, so that is the log di of kanang x times y ni siya, sorry. The log di of the product of two resulting numbers or two numbers x and y with the base of a is just equal to unsa man? Equal to the sum of their exponents, di ba? Naman na dire. The exponent of x and the exponent of y. So, unsa may exponent ni x, di ba? N. So put here n plus the exponent of y, which is m. And now, how are we going to get for the values of n and m in terms of x and the base a? So balik ta ani atong gilet, diba? Sa x, si x daw is equals to a raised to n. Now this is an exponential form. If we're going to transform this into logarithmic na form, diba? Ang resulting, ang transformation niya is write first the exponent, kaya mo man answer sa logarithm, is equals to the log of the number. What is the number? X to the base a. The same thing with y is equals to a raised to m. Unsay exponent ani? Si m. Mo na ang resulting sa logarithmic, which is equal to the log of the number y to the base of a. So mo na imo na siya kuan dito, imo na i-substitute. Therefore, we have log of the product x and y to the base a is just equal to the sum of their exponents, n plus m. Then n is equal to log of x to the base a plus log of y to the base a. So, mo na nga ito na na-prove nga kana siya nga property is correct or may exist. So, now in the natural logarithmic side, that is the ln of x multiplied by y is just equal to the ln of x plus the ln of y. Nga na siya class. Then after this, ato pod ma-derive ang kuan. Kaya kani siya, kaniyang property is the product of two numbers. Napod tayo the quotient of two numbers. Ang division nga side. Sa ni erase. So mo jump ta sa ika-unom. nga property. So here ang kuan na pod ang quotient sa duha ka numbers, let's say that is the log of the quotient of two numbers x and y to the base of a is just equal to the difference of their exponent, that is log of x to the base of a minus log of y to the base of a. So difference lang daw. Again, kung multiplication or the product of two numbers, ang resulting anak niya is just the sum of their exponents or the sum of the logarithm. Sa dire, sa division is the difference of the logarithm or the difference of their exponents. So unsa na ito pag-prove? In order to prove this, gamit lang pud ato. Let's say we let katarapod ganiha x is equals to a raised to n, then our y is equals to a raised to m. So if we're going to divide x and y, that is x over y is just equal to a raised to n all over a raised to m. That is equal to a raised to n minus m. So diba, naman ni nga relationship, that is x y is equals to a raised to n minus m. Diba? This is an exponential form. So kani siya, this one is an exponential notation or exponential form. Now, ato na siya i-convert into logarithmic form. So again, as ito'y logarithmic form, just write the log of the number. Unsa may number or the resulting number niya kaning sa left side, that is x over y. Then unsa may base niya kaning a. So put here base a is equals to the exponent. Unsa may exponent niya kaning n minus m, that is n minus m. So ato gid na prove nga ang difference sa lang exponent. Now, ang problema ani kay pangitaon ning si n og si m. So balik ta sa atong pag initialize aning mga values, variables. In order to solve for n, i-convert na po ni si x is equals to a raised to n into logarithmic form. So convert ni siya. Write first the logarithmic of the resulting number, that is x to the base of a is equal to the answer, the exponent. So exponent ay n. The same thing with y. So y is equals to a raised to m. I-convert niya. Again, the logarithmic of the resulting number, that is y to the base a is equal to the exponent m. So naraman tayo n of m ari. Ato na siya substitute. Dili day. Kaya siya. Ato na siya substitute ari. So therefore, kani siya, mahimo na siya og log of x all over y to the base of a is equals to n. Ang sarap ang n, naara. Kani siya. That is log of a to the x, log of x to the base a minus kay n minus m man. Ang m kay kanina po siya. So that is a log of y to the base a. So therefore, na-prove na to ang ikaunom nga property. Now, in terms of the natural logarithm, that is just the ln of x divided by y is just simply equal to ln of x. Yan ito ning kanon erase kay marmalain. So that is ln of x minus the ln of y. So mana siya ang division property. Now, proceed ta sa power rule. So, the same with exponent, mandrago po ta og power rule ani. So, again, ay ni kalimti mga properties kaya importante ni siya, especially kung mag-simplify ta. So, ikapito, gitawag og kanang power rule. So, for the power rule, that is the logarithm of x daw raised to the power of n. So, ang atong resulting number ani kay nanapod siya exponent. So, unsa equivalent ani niya class? That is just equal to the n log of x to the base a. Again, kani ato ring nasugatan ganiha or sa mga previous na mga discussions. Mo na og gingon ninyo nga simply di class kung naa moy logarithm sa usa ka number nga gi-raise per exponent, ang transformation niya is just imo na i-bring down, simply bring down sa exponent tapad niya. Mao na ang naatay diri n log of x to the base a. Pero giunsa man ni pag-achieve. So, i-let rata para ma-verify niya. We say that the log of a x raised to the power of n is equal to a certain exponent, diba? The resulting number for your logarithm is the exponent. So let's say m here is our exponent, a real number. Exponent na siya. And then we also let a certain variable, let's say x raised to n. I mean, this is not initialization by class. Kani siya ato na i-convert into exponential form. Diba? Ang sa exponential form, the resulting number x raised to n is just equal to the base. Sa base ani a, and then raised to the exponent. Sa exponent ani the result of the logarithm, which is equal to m. That's equal to m. Okay. Then we represent another class. We represent another value for our x here. So let's say representing another parameter. Another parameter for x. Actually, mali na kayo sa mathematics class kay daghang kag pwede ma-let basta kay mo follow lang ka sa rules sa mathematics. So here we can say that x is equals to the same gihapon nga base a but different na siya nga exponent. Let's say I will let here a raised to c, exponent c, wherein c approaches or as an element of a real number. So real number gihapon na siya. So here makaingon ta nga si x di is equals to a raised to c. So naman ta diri kaning equation ato na siya substitute ang value sa x. So that is a raised to c raised to n, diba? Is equal to a raised to m. So what happens here? Kani i-multiply, so that would be a raised to cn is equals to a raised to m. So recall sa pag simplify og kanang exponential equation, diba? Same ila base. So therefore, we can simply equate their exponents. That is cn is equals to m. Now, kung inyo makita class, diba? Si m di is simply the product of c and n. So ato na siya i-substitute nga ri sa first. So therefore, mingan ta nga si log of x raised to the power of n with the base a is just equal to m, which is equal to cn. That is cn. And what is c, by the way? Diba? But c is kaniyang c kay naan siya sa kaniya atong represent x equals to ac. So recall that x is equals to ac. Now, changing this one into logarithmic form, that is the logarithm of the answer, which is x, to the base of a is just equal to the exponent c. So therefore, mo na atong value sa c. Ato na i-substitute ari a. So we now have, therefore, we now have log of a number x raised to the power of n is just equal to the n multiplied by the c. So mo man ang c. So ang c is just log of x to the base a. So therefore, atong na-prove ang ika-pito nga property, ang power rule nga property. Mo ni siya class. And then, by using the natural logarithm, this is just the ln of x raised to the power of n is just equal to the n ln of x. Mora. So let's jump with the last. Ang kinalasan nga property class kay gitawag nga change of base. Importante ning change of base. So sa change of base, kinahanglan ko diri ang kuan. Na diri ang taking apart kaning nga property, kaning last nga property pod, ang change of base. So ika 8. Now, in the change of base, I think nakuha na ako ganiha. So, ang change of base, if we have the logarithm of x to the base of a, so, kani siya, change of base ni siya, change of base. Meaning, ang pasabot ani, ang resulting ani is lahi na nga base, kay mag-change man ang base. So, kung maglahi tag base, kung mag-represent tawag another base class, ang relationship between this variable x and the a is just simply equal to the logarithm of x to another base. Let's say that is the base c. all over the logarithm of the base a na with respect, the logarithm of the base a with the base c. So here, c muna siya to ang another base. Okay. Unsa na to pag pagkuan class? Unsa na to pag kuha or pag prove? So mag-start ta by saying that the logarithm of x to the base a is some exponent, di ba? Ang resulta ng exponent, so that some exponent m. Okay, m here is an exponent. So we can say if we're going to change this one into exponential form, that is just simply equal to the resulting number x, di ba? Equal na siya. So ito i-erase. That is the resulting number x equal to the base a raised to the power of the resulting number of the logarithm, which is m, a raised to m. Okay, then we are going to solve for that m. Okay, magid na itong ipangita. Solve for m, ang resulting sa logarithm. In order to solve for m class, again, sa mathematics, okay na dyan maglet-let ta as long as follow ka sa rules. So, let's say maglet ko og x is equals to an exponential number that is of the base c. Kaya diba, mag-change matag another base nga c. So ako i-let niya nga another base akong gamiton nga c raised to a certain exponent, let's say that is q. Okay, daghan na tagi pang representing nga variable, no? It's okay lang as long as mo follow ta. And then si a pod ari, since maglahi matag base, so si a naapoy base nga c, same ni x, para same sila. Then raised to the power of another exponent r. Now, kung ato ni i-convert into logarithmic form, that is just the logarithm of the resulting number, that is x, to the base of sa may base ani, that is c, is equals to q. And the same thing with this, that is just the logarithm of a to the base c is equals to r. Okay. Now, na naman ta ni paglet nato. So, ang ato buhaton ani is unsa man? Balik ta ani exponential form, di ba? Naman ta ani. So kung nata ani, nya naglet naman pud ta, ato is substitute ning value sa x ug sa a. So from there, that is x is equals to am. Ang sagad sa x is equals to c raised to q. So that is c raised to q is equal to, ang a here is c raised to r raised to m. So simplifying further, that is cq is equals to c multiplied by rm. Since the same man nila base, so we can just equate the exponent. So that is q is equal to rm. Since si m man itong ipangita, so divide both sides by r. Now, ang m na to is equals to q over r. So here, balik na punta ka ni nga form, ato po na siya ikuan dili. Ato na siya i-rewrite in terms of the value of m. So that is log of x to the base a is equals to m, wherein m is equals to the q all over r. Now, ato na siya, ang q ug r, ato na siya i-substitute in terms of the logarithmic form. So, kana siya. Diba? Naaman ta, gilet naman nato diri. Si q daw is equals to log of x to the base c all over si r log of a to the base c. So therefore, mo din ang pag-change of base if you're given a certain logarithm. Mo na siya ang resulta. So di ba? Ato na prove ang ika-7 ika-8 nga property sa logarithm. Okay, unsa may example ni class? Example. Let's say if you're given a log of 32 to the base of 4, pwede na niyo ma-solve using another base. Let's say, ang pinaka-common mo sa calculator kay base 10. So, you can just write simply log of 32 to the base 10 na siya automatic all over log of 4 to the base 10. Now, kung imo na siya i-solve using calculator, again, kung na may calculator, isolve na to ang log of 32 sa, that is log of 32 to the base 4. Ang answer kay 5 halves or 2.5. This one is 2.5. Equal ba na siya sa log of 32 over log of 10? So, kung sa inyong calculator, i-plug nimo ang log of 32. So wala na siya base, ang base ani kay 10. So log of 32 ang answer kay 1.5051499. So ato isuwat to be exact, that is 1.505149978. How about log of 4? Log of 4 is 0.60, so that is 0.6020599913. Okay, bisag kanila ang values ito i-simplify. That is 1.505149978 divided by 0.60205123 then 13. The answer, class, is 2.5. So therefore, na-prove na to. So diba? Inganalan nimo, class. Pwede ka makasolve sa usa ka logarithmic nga number into another logarithmic number nga lahi pud siya og base. So mana siya gitawag nga change of base. Applying this one to our natural logarithm, that is just the ln of x is just equal to the ln of x all over unsa gali ang base sa natural logarithm, that is ln of e. So ln of e. Okay, mako na po di nga naggali, class, di ba? Remember sa ato ang second nga property sa logarithm, di ba? If you have the log of a to the base a, that is just equal to 1. Why? Because if you're going to change this exponential in exponential form, that is just the resulting number a is equal to the base here is a raised to the exponent here 1. So di ba equal sila? So here ang ln of e is equals to 1. So manang we have ln of x is equals to ln of x. So na-verify na po nato ang change of base sa natural logarithm. But tungod kay understood naman gud nga for any kuan, kay since fixed man ang base sa natural logarithm, so mas gamit ang kaning property nga change of base sa common logarithm. Kay sa common logarithm ba kay lahi-lahi man ang base any number man. So mao ni siya. And since we are already done with the properties, proceed ta sa methods on how to expand a logarithmic expression. So mampod ni ang medyo challenging ari kay, of course, dapat kay bawta mo simplify or mo modify sa ato ang logarithmic expression. So let's start by expanding the logarithmic expression. Let's say if you are given this expression, log of 10x squared y cubed to the base of 5. Now we're going to expand this one such that ato i-separate the constant, separate also the variable x, and separate also the variable y. So di ba unsa man pag if na kay logarithm, unsa ra gud tawag kung mag-separate ka, di ba? Ato siya itagsa-tagsa ka mga terms. So kung ato siya itagsa-tagsa ka mga terms, ang operation na kay either addition or subtraction. So operation na ni kay either addition or subtraction. Okay. So di ba ang kanisiya naani siya sa, I think ikaunom sa atang property, di ba? We already know the property nga log of, let's say this is m multiplied by n to the base a, diba? This is just simply the log of m to the base a plus the log of n to the base a. Bahala pa nagdaghan na siya, let's say naka expression nga, let's say that this is x, y, z, k to the base a. Basta kay same na silang base, i-add ra ilahang mga resulting logarithm. So that is the resulting logarithm for x to the base a plus the resulting logarithm of y to the base a plus the resulting logarithm of k to the base a. Simply add their exponents. Why? Diba? Sa principle ana, marara mo na siya kuan. Marara na siya og a raised to n, that is for x, and then a raised to o is for y, then a raised to p is equals z, then a raised to q is equals to k. Diba kung ato i-multiply si x, y, z, k, equal po na siya sa an multiplied by a0 times ap times aq. Nya, diba? Same man silang base. That is equal to a raised to n plus o plus p plus q. And diba? Ang logarithm kay nag-represent sa exponent. So, kita ang behavior sa exponent, diba? Na-add sila. Mao nang diri pod, na-add pod siya. Okay, so mao na siya ang application sa properties. Now, kung ato ni apply nga principle sa ato ang given, since ang goal nato ani kay i-expand man by expand, so masiparit na ning mga constant and variables. So kani siya, this can be rewritten as the log of 10 to the base 5, separate na ang constant, plus the log of x squared to the base of 5, plus the log of y cubed to the base of 5. So ato goal pod kay eliminate exponent sa atong number. Eliminate exponent on the number or the resulting number. Diba? Unsa to yung mga numbers na to ari or variables kaning 10, x squared and y cubed. Dapat wala sila mga exponent. So for 10, 1 na lang ni siya, so retain na siya. Plus for log of x squared to the base 5, remember sa property nga if we have log of x raised to n to the base a, that is just equal to kani siya mabutang ara, so that would be n log of x to the base a. Mo na to i-apply dira kung naatay mga exponent sa ato ang resulting number. So applying that sa ato example, kana siya mahimo na siyang plus 2 log of x na lang to the base of 5 plus the same thing here, madapot si 3, then log of y to the base 5. Now, kung si 3 diri negative, ma-negative na po siya diri. So, follow lang the sign. So, therefore, mo na siya ang iyahang expanded form. Mo na iyahang expanded form. Let's try another one. So, second example, we have the natural logarithm of this expression, that is square root of 2x minus 3, then all over 4. Again, i-expand ni siya. So, ma-apply ani para ma-expand ni siya and ma-separate ang mga terms separated by addition and subtraction nga sign. So, ma-apply ni ang division rule. Why? Because kani siya division rule over property, because this is just equivalent to say you have ln of x all over y, di ba? Then, unsa equivalent na gud, that is just equal to ln of x minus ln of y. Okay, division ni siya. So, applying this sa ato ang expression, so mahimo na siya og ln of square root of 2x minus 3 minus the denominator ln of 4. Now, kaning square root of 2x minus 3, para ma-eliminate nato ang square root, let's say we're going to eliminate square root or eliminate radical symbol day. Eliminate radical symbol. So, what will we do? Para makuha ang radical, ato na siya i-change into exponential. So, this would equal to ln of 2x minus 3 raised to 1/2, diba? Mamuna equivalent na exponential form kung square root minus ln of 4. Okay. Kani siya, apply na po to ato ang property nga ln of x raised to n is just equal to n ln of x, di ba? Matapad rin siya. So therefore, kana siya is equal to 1/2 ln of 2x minus 3 minus ln of 4. So mo na siya ang iyahang expanded form nga wala nay exponent sa ato ang resulting numbers. Okay, let's try another. So, third example, let's say you are given here log of the product of x times the square root of x squared plus 2 to the base of 2. So, ma-apply na to diri ang multiplication rule. Multiplication rule. Again, unsa lagi property nga ma-apply ani? That is log of x and y to a certain base a is just equal to the sum of their logarithms. That is just log of x to the base a plus log of y to the base a. So here, ato na i-apply nga rule, that is just log of x, mamanay una na to the base of 2. So kani siya to the base 2 ni siya. To the base of 2 plus the log of the square root of x squared plus 2 to the base of 2. So diri ato i-eliminate radical sign. So ato na siya i-change into exponential form, that is just log of x to the base of 2 plus the log of x squared plus 2 raised to exponent 1/2 to the base of 2. Now applying the power rule, that is the log of x to the raised to n to the base a is just equal to the n log of x to the base a. Applying that, so we have log of x to the base 2 plus here, mabali na ni, matapad yung 1/2, that would be 1/2 log of x squared plus 2 to the base of 2. Again, kana siya sa logarithm class ha, logarithm of the expression. Kani siya, basic na uban mo answer ni siya sila og 1/2 multiplied by the log of x squared to the base 2 plus the log of 2 to the base 2. Di ni siya equal. Wrong ni siya tungod kay kung mag-sum ka o expression inside the logarithm, di ni siya equal po the sum sa exponent. Lahi na siya. Ma-apply ra ni nga property kung product sa duha ka numbers. Okay. So, since humanata sa expanding logarithmic function, dito sa pamaagi unsa ang pag-condense sa logarithmic expression. Now, reverse po niya sa pag-expand sa logarithmic expression. Sa condense, gihatagan na po og kanang expanded nga logarithmic expression. Ato na po siya i-condense back. So here, first example is 1/3. Then we have log of x to the base 10, or di na to susuwaton kay understood naman, plus 5 log of x plus 2 to the base 10. So ibato ay nato. First thing you need to do is i-condense ang condense exponent or apply power rule. Apply the power kanang katong power rule nga property ba. Apply this one, di ba? If you have log of x raised to n to the base a is just equal to n log of x to the base a. So, di ba, kung hatagan mo ani, or yan na lang, if napagay ni variable, napagay ni constant ang logarithm before niya, nga nag-precede niya, meaning, imo na siya i-balik na po nga to sa exponent sa expression. Di ba, maman itong ibuhat ganiha, so reverse man ta, imong balikon. So, here naman tayo, example nga usa, ang duha jud kaning 1/3, ibalik nga to, kaning si 5, ibalik po nga to. So, this will now be equal to log of x raised to 1/3 plus log of x plus 2 raised to 5. Now, we have, naata diri fractional exponent. So, unsa ra gud kung fractional exponent ta, ato siya i-change into radical expression. So, kani may man siya og log of, this is cube root of x plus the log of x plus 2 raised to the 5. Since na okay na ang sunod buhaton, since nakaseparate pa man siya og addition, now change addition to multiplication property. Ang sagot to sa property na to, kung nag-add ka og duha ka logarithm, the same sila ha. Maka-add ka og logarithm, maka-condense ka og logarithm kung same sila og base. Balag di sila same og expression, basta same lang og base. Since same sila og base, so we can just say this one is the log of, so karon ato sa day pakita ang property niya. Diba ang property sa multiplication, if we have log of x and y to the base of a, that is just equal to the log of x to the base a plus the log of y to the base a. So ang buhaton na dahil kay i-multiply ra ning duha ka expressions ni ini. Multiply ra. So here at i-multiply, that is log of cube root of x multiplied by x plus 2 raised to 5 to the base of 10. Therefore, mo ni ang answer. Mo ni ang condensed nga logarithmic expression. Yan na class. So, pwede pa ni siya i-multiply tag sa tag or i-expand siya pero mas taas naman good. So, kani in factored form lang ni siya. Pwede na siya ang answer. Okay, let's move to the second example. Kaduha nga example, you are given a 5 loan of 3x plus 2 minus loan of x. Again, unaha sa ang kanang if naabay constant nga before sa logarithmic expression. Kay if naa mo apply ta og katong expression sa natural logarithm, that is if we have ln of x raised to the power of n is just equal to the n ln of x. So atong buhaton kay butang na siya sa exponent. So here ang 5 mabutang sa bilang exponent. So that is ln of 3x minus 2 raised to the 5 minus ln of x. So since this is division, this is subtraction di ay. Since nag-subtract mo taog logarithmic expression, so subtraction, unsay conversion na niya? Ma-convert na siya into division, di ba? Division of the exponents. Mo na siya kung mag-subtract ka og logarithmic, ang kana na kay nag-divide ka og duha ka numbers. So here, we can say that that is ln of 3x minus 2 raised to 5 all over x. So, mo na siya class. Kasi in subtraction man, division ato ang gamiton pag condense. Okay, how about this? For the last example, here you are given last example for number 3, that is 1/2 multiplied by the log of x to the base 2 plus the log of x minus 4 to the base of 2. Itong buhatan ani kay ato sa simplify ang expression. So kani ato simplify, multiply both sides, that is 1/2 ln of 2 to log of 2 to the base 2 plus 1/2 log of x plus 4, this is minus the this one is x minus 4, that is log of x minus 4 to the base of 2. So since naman tayo power rule, so apply log of x raised to n to the base a is just equal to the n log of x to the base a. So applying, that would be log of x raised to 1/2 to the base of 2 plus log of x minus 4 raised to 1/2 to the base of 2. Then convert to radical expression. So may man siya og log of square root of x to the base of 2 plus the log of the square root of x minus 4 to the base of 2. Then, from addition, convert to multiplication nga rule sa atong property, di ba? Multiplication. So, multiply na lang sa ilahang expression kansiya. Okay, the same sa base, so we can condense them. That is log of square root of x multiplied by the square root of x minus 4 to the base of 2. Now here class, pwede ba ni masod sila, di ba simplify man from the properties of radical, that is square root of a multiplied by square root of a, the answer is the square root of ab. Kung the same sila index, mausa ang sod ng expression. So kani, this will be further simplified as log of square root of x times x minus 4 to the base of 2. So, pwede kaya ni siya. Or you can also simplify the inside of the radical sign. So, pwede ra pod. So, mana ang pamaagi sa pag-condense o pag-expand pod sa previous sa logarithmic expression. So, just remember yun sa mga sa class. Mga properties sa ato ang logarithmic expression. From logarithmic, from common logarithm until sa natural nga logarithm pod. So, ang sarap itong buhatan is, of course, dapat kay babuta mo solve og logarithmic equations and exponential equations pod. So let's start with the first example. Let's say if you're given a natural logarithm of x is equal to -4. Here we are going to solve for x. So diba, if we're going to change it, since this is in a logarithmic form, ang pinaka best way nga mo solve tani sa x is by changing this one into exponential form. So, diba? Ang sa may exponential form nini, that is, we are going to write the resulting number. Ang sa may resulting number, that is x, is equal to, ang sa may base, diba? For natural logarithm, ang base kay e raised to, diba? For every answer sa ato ang natural logarithm or the normal or the common logarithm, alang answer mo na siya nag-indicate sa ato ang exponent, that is e raised to -4. So here, simplifying, you can also write this as 1 over e to the 4th. Kung naka-calculator, that is approximately, that is e raised to -4, that is approximately 0.018. So this one is 0.018. That. Okay, muna siya ang value sa ato ang x. Okay, let's try another one. For number 2, let's say you are given 5e raised to 3x minus 4 is equal to 2. So, kani siya naka-exponential form ni siya. So, kani, since kani siya constant, so ito sa i-combine daan para dili na ma-complicate ato ang expression, equation. So, that is be 5e raised to 3x is equals to 4 plus 2, that is 6. So that is, we are going to divide 5 para sa e na lang yun nga in terms of x. On the left side, that is e raised to 3x is equals to 6 over 5. So here, ang ato na po variable kay nasa exponent. So, what we're going to do here is to, convert to logarithmic, di ba? Logarithmic equation, di ba? Dire, since si x kay naman sa sud sa logarithmic, i-change siya into exponential. Since dire kay ang variable kay nasa sa exponent, i-change siya into logarithmic. So, unsay equivalent niya ni? Di ba? Unsay ko to? The logarithm of the resulting answer, unsa man, that is 6 over 5. That is 6 over 5 to the base of unsa man e. So since ang base niya kay e, we're gonna use ln. So that is ln. So we have here ln is equal to the exponent. So may exponent diri, that is 3x. That is 3x. Now si x man tong pakita, so divide both sides by 3. Therefore si x now is equals to the ln of kani, pwede po natin ibutang sa tagsa, di ba? Kay this is division. Let's say we can subtract them. That is ln of 6 minus ln of 5 divided by 3. Now may calculator. So, simplifying that one, that would be equal to the ln of 6 minus ln of 5 divided by 3. The answer is approximately 0.06. Daghan pa ka na siya mga periods. That is 0.06 blah blah blah. Manay value sa atong x. Actually, class, napoy pamaagi ani pag-solve nini. Kani siya. Kani e raised to 3x is equals to 6 over 5. Ang gitawag kay take pwede po logarithm of both sides or take natural logarithm on both sides. Muraratag sa atong pa previous nga mga discussions like if natay square root on both sides, di ba mo take po ta og square both sides. So kung nag-square ta sa both sides, kung nag-square ta sa one side, mas square po ka sa both sides. The same thing with here. Kung nag-apply tag lone sa usa ka side, mo apply po ta og lone sa other side. So applying that one, natay lone of e raised to 3x is equals to the lone of 6 over 5. Now, applying the properties, di ba naman tayo exponent array para makuha ng kuan ma-extract na siya. So, di ba mabalhin na array from the properties of our natural logarithm. So, may mo na siya og 3x ln of e is equals to ln of 6 over 5. So, here, nasa exponent ang variable. So, maka-divide din ta simply. Divide by ln of e. So, that is, divide by 3 pa jud. Pa sa x na lang yun. That is x is equals to ln of 6 divided by 5 all over here. Diba? Ang ln of e is equals to 1 sa itong property. So, mahimo na siya og 3. So, therefore, kani siya nga expression kay pareharaan ni ganiha. So, either way, you will get the same answer. So, pwede ka magamit sa first, kaning convert lang ang exponential form into logarithmic, or you can take the natural logarithmic on both sides. So, it's up to you, class. Asa ka kapanti. Okay. So, let's proceed. The next example. Now, sa next example, class, medyo fancy na-tricky gamay. So, na-tricky gamay. Sa next example. Let's say you are given, for example, number 3, gihatagan mo og e raised to 2x minus 3e raised to x plus 2 is equals to 0. So here, can we combine this? Dili, tungod kay lahi sila og exponents. Although same sila base, but lahi sila og exponent. Kung sa'yo pamaagi na ito ani. Kung ato po manggod ingat to ni siya sa pika side, then let's say that is e 2x minus 3x equals to negative 2. Then, since napaman sa variable mga variables, naa sa exponent ng mga variables, so we're going to take the ln of both sides. So, kung may ganita, 3e raised to x is equals to the ln of negative 2. Now, naaba tayo ln of a negative number. Diba? Wala. Ln of negative number, that is math error. So, therefore, di ganyan siya nga pwede nga pamaagi. So, pamaagi, class, kung makasugat ang ingana. Okay, medyo tricky mo nga part, pero magamit ato ang mathematical ability ni ini. So, as you can see right here, class, if I'm going to mag-let ko let y is equals to e raised to x. Now, if we're going to square y, that is, kung mo square ta both sides, di ba, mahimo pa siya og y square is equals to e raised to, ang x multiply sa 2, that is to e raised to 2x. Now, ato ni siya i-substitute sa ato ang exponential equation, mahimo na siya og y squared, di ba? Ang y squared kay 2x. Minus 3 times e to the x is y plus 2 is equals to 0. Now, we can solve y, class, and then after solving the y, ato na po i-plug in diri sa atong gilet nga value, di ba? Inga na siya. So, himo day nga equation kay, unsa man? Quadratic. Mag-iana kay style class sa mga equation, class, quadratic dahin ka. Ang mga na e raised to 2x niya. Ang usa na pod ka term kay mo e to the x na lang. Alams na ang pattern, quadratic siya. So here, we are going to solve for y, trial and error. The factor would be y minus 1 multiplied by y minus 2. So, mo result siya sa middle term. Therefore, we have two roots. The first one is y minus 1 equals to 0. That is y sub 1 is equals to 1. Y minus 2 is equals to 0. Y sub 2 is equals to 2. Duha ang atong answer sa y. Now, ato i-try kung asa ani ang iyang answer. So, try at y is equals to 1. Diba? We all know that y is equals to e raised to x. That is 1 is equals to e raised to x. Now, this is an exponential form. Convert into logarithmic para makuha si x. That is the logarithm of the resulting answer, which is 1 to the base of e. Or we can just use the natural logarithm. Kay e mo gana siya. So, here we can say that the ln of 1 is equals to x. So x di ay nato is equals to ln of 1. Unsa man ang ln of 1 sa calculator? Ln of 1 is equals to 0. This is 0. So therefore, mana atong value sa x sub 1. Then, how about if y is equals to 2? So that is 2 is equals to e raised to x. Then, transforming it into a natural logarithm, that is the ln of the resulting answer 2 is equals to the exponent, diba? X. So therefore, x is equals to the ln of 2. Simplifying further, that is equivalent to ln of 2 kay 0.693. That is approximately 0.693 blah blah blah. Muna ito ang ikaduhang value. So therefore, we have two solutions here. X are the solutions 0 and 0.693 blah blah blah. So muna itong solution sa ito ang logarithmic, exponential expression. Ay gini kalimti class. So again, para masabdan pa ninyo, magdagdag tag similar nga kanani, similar ani nga forma kaning exponential form nga na siya quadratic. Okay, so ikaapat example. Let's say we are given e raised to 4x plus 5e raised to 2x, then minus 24 is equal to 0. So kani siya quadratic ni siya. So saan pag nato ani maglet na punta. Let y is equals to, let's say, e to the 2x. So if we're going to take the square both sides, so we have y is equals to e raised to 4x. Now wala na ako giingon nga y is equals to e to the x lang kay di ta ma-create og quadratic, mahimo siya og fourth kanang quartic. So ato lang i-combine directly ang variable sa middle term at then gilet og y. So na naman tani, substituting that values sa ato ang original nga quadratic equation, that will be equal to y squared plus 5y minus 24 is equals to 0. And then this is now a quadratic formula, quadratic equation. Solving for its class sa iyahang isolve na to ang iyahang iyahang roots, that would be y, and then here positive 5, so we can use 8 times 6 times 3 6 times 4 or 8 times 3 so that is y plus 8 then y minus 3, diba? Mo result siya sa middle term, diba mo result siya. So therefore we have two roots here, so we have y plus 8 is equals to 0, therefore y sub 1 is equals to negative 8. Kaduha, y minus 3 is equals to 0, that is y sub 2 is equals to 3. Now ato siya i-check sa ato ang gipanglet. So at y sub 1 is equals to negative 8, so we have here sa atong gi-initialize kana siya, that is y is equals to e raised to 2x. So that is y is negative 8 is equals to e raised to 2x. Now changing this one into natural logarithmic form, that is the ln of the answer negative 8 is just equal to the exponent. So exponent ano yan kani? 2x. So that is equal to 2x. Divide both sides by 2. X is equals to the natural logarithm of negative 8 divide by 2. Now, unsa may answer sa ln of negative 8? That is an error. So dili data pwede dili pwede si x ani. So therefore wala tay value sa x ni ini. This one is undefined. So for x sub 1 at y1 is equals to negative 8, ma-define siya. Okay. How about if at y1 gihapon is equals to y2 day. How about y2 is equals to 3? So that is y is equals to e raised to 2x. Then y is equals to 3 here, so 3 is equals to e raised to 2x. Convert this one into logarithmic form, that is the ln of 3 is equals to the exponent, which is 2x. Divide both sides by 2. Our x here is ln of 3 divided by 2. That is equivalent to ln of 3 divided by 2 equal to approximately 0.55. This one is 0.55 0.55 yun. Blah blah blah. So mana siya ang value sa atong x. Now usa ra tong value sa x kay kaduha, di ba, kay nag-agitag quadratic. Kaduha man good kay sa man undefined man siya because we don't have ln of a negative number. So si 3 si x is equivalent to 0.55 rigid ang masatisfy ani niya. So pwede po niyo i-check class kanito mga answer, pwede po niyo i-check para makuha ninyo nga correct ato assumption. Correct na itong answer. Okay, so balik ta. So more na siya example number 4. So let's proceed to example number 5 para maanad din mo. Example number 5. Let's say natay logarithmic nga expression or equation. The log of 5x minus 1 to the base of 3, that is equal to the log of x plus 7 to the base of 3. Now, if makasukat po yung ni class equation for logarithm class, ang goal nato is to have the same base. Nga naman, if ang both sides of the equation is of this form, let's say if you have log of x to the base a is equals to the log of y to the base a, di ba? Usama ni siya sa mga properties. Then makaingon ta nga si x is equals to y. So applying that one in our example, since they have the same base equal to 3, so therefore we can just equate their expressions. Kaning ilang expression sa logarithm, equate na directly. So that is 5x minus 1 is equals to x plus 7. So linear equation is siya with a variable x. So transpose on the other side, negative 1 transpose on the other side, that is 5x minus x is equals to 7 plus 1, that is 4x is equals to 8 divided by 4. X here is equals to 2. Okay, 8 divided by 4 is equals to 2. So mo na siyang value sa atong x. How about for example number 6? Here we are given a log of x plus 6 to the base of 5 plus log of log of x plus 2 to the base of 5 is equal to 1. Now, ari a class, bito na to ma-achieve dahil ang kanisiya. Diri amang good, kanisiya di na to ma-go directly ani y because naman go take constant nga 1. So, what we need to do here kay ato sa ni siya i-compressed or i-condense. Diba? This is kanang the sum of the two logarithm niya. Same pigil sila base, so ato na siya ma-compress. So again, kung addition gani siya, if this is addition, convert to multiplication, di ba? Equivalent niya kay multiplication. So that is the log of x plus 6 multiplied by x plus 2 with the base of 5 is equals to 1. Here, this is a logarithmic form, di ba? We can convert it into exponential. Para ma-solve na to ang values ng x. So, converting that, write the resulting number. Di ba? Ang resulting number is inside the logical expression, that is x plus 6 multiplied by x plus 2 is equal to, so may base na to rin, that is 5. Raised to the answer, muna itong exponent, that is 5 raised to 1 or 5. Here, we can simplify this, that is x squared plus 2x plus 6x plus 12 is equals to 5. So this will be x squared plus 8x. So can you see ito like a transpose on the other side? So 12 minus 5 is equal to 7. That is 8x plus 7 is equal to 0. Now, ato ni siya find the roots kay since this is quadratic. This is a quadratic equation. So, di ba? Kung ano naman tamo kung sa mga pamaagi pag-solve sa roots or mga pamaagi sa pag-solve ng quadratic equation. So, here we can factor out, we can find its factor, that is x plus 7, then x plus 1. So, result siya of 8 is equals to 0. Now, solving for the roots, that is x plus 7 is equals to 0. So, therefore, x sub 1 is equals to negative 7. Then, x plus 1 is equals to 0. X sub 2 is equals to negative 1. Therefore, natay duha ka solution sa atong x. So, here, x equals to the solution set of negative 7 and negative 1. So, manay value sa atong x dira. Now, pwede po na ninyo ma-substitute class para ma-verify ninyo. Okay. So, let's have another example pa dyan para ma-practice. Para ma-practice yun mo. So, for number 6, you are given number 7 data. Sorry. This is number 7. So, for number 7, you have here log of x plus 2 to the base of 2 minus log of x minus 5 to the base of 2 is equals to 3. Kani siya, di po na ito ma-use ang kanto ang dili ni maoning katong log of x to the base a is equals to log of y to the base a. Nga naman, tungod ani nga constant. So, therefore, dili ni gamit siya. So, atin siya sa balik. Ang ato lang only way is, we can condense the left side, di ba? Kani, pwede na makuan class. Okay, wait lang, nag-loading. So, kani siya, pwede na makondense. So, kani siya, pwede na makondense. Since, the same man sila base, then the operation is subtraction. So, di ba? If that is subtraction, ma-convert na siya into division. Meaning, ma-divide ang ato ang mga numbers or expressions inside the logarithm. So, that is the log of x plus 2 divided by x minus 5 with the base of 2 is equal to 3. Now, this is in a logarithmic form. Now, you can proceed this one into exponential form. So, that is the number x plus 2 or the resulting number or expression x minus 5 is equal to the base. The base is 2 raised to the unsa gali answer sa logarithm of the resulting number, mo na siya ang exponent nato, that is 2 raised to the power of 3. Okay, ang answer sa logarithm always mo na siya ang exponent sa imong base. So here 2 cubed is equal to 8, di ba? This is 8. So therefore, having the cross multiplication, so we have 8x minus 8 times 5 is 40 is equal to x plus 2. Now, ato siya transpose on the other side and transpose on the other side, that is 8x minus x is equals to 2 plus 40. So 8x minus x is equals to 7x. 2 plus 40 is 42. So divide both sides by 7. So x now is equals to 6, diba? 42 divided by 7 is 6. Okay, so mara siya ang value sa ato ang x, sa ato ang given nga logarithmic equation. Okay. About for example number 8. Example number 8. Okay, let's say if you are given ln of the square root of x plus 3 is equal to 1. Okay. Ang ato ani, since na may square root, pwede po na ito pwede na ito ma-convert into katong gamit na to ang power rule. Pwede po or pwede po ka largo dahil o convert ani into exponential form. Kaya diba? If we're going to convert it into exponential form, this would be equal to the resulting number, that is the expression pod inside the natural logarithm is equals to the base. So may base na to ani. For natural, that is e. Raised to the answer for the natural logarithm, that is the exponent 1. So here, e to the 1 or simply e. Now, since naka-square root na siya, so we can square both sides para matanggal na yung square root. That would be x plus 3 is equals to e to the power of 2. Then, transpose on the other side, that is x equals to e to the power of 2 minus 3. Simplifying further, x here is approximately e to the power of 2 minus 3. The answer is 4.39. Approximately 4.39 ... So, mana ang value sa ato ang x. Okay. So, let's proceed to the last example. Ang last example, medyo tricky siya gamay, pero makuha na nato. For our last example, example number 9, we have here a logarithmic problem. Super simple na siya. If, okay, may anak ko na siya. Kiingon nga, if log of 2 daw, so log of 2 is equals to x, and log of 3 is equals to y. Again, ang base na to ani is 10. Then, ingin siya nga, find daw kuno, find log of 1.2. In terms daw kuno of, in terms of x and y. Okay, sa ato pag-solve ni ini. So, gihatag man ta the log of 1.2. Okay, to the base of 10 na siya. We don't know. But kaning 1.2 class, we can rewrite this. Diba? Ang 1.2 kay unsa man na siya? Ang 1.2 kay kung ato na siya ikuan, that is 6 divided by 5. So, diba? 1.2, ang equivalent sa 1.2 is that is 6/5. Kung division siya, kung division. But ato kung ana ni goal kay si 1.2 ato siya ma-represent as a product or a quotient of the combination of this number 2 and 3 para mas madali siya. So unsa man, let's say 12, di ba? Unsa may makuan sa 12, di ba? Or I mean ang 12 or 1.2 unsa man kaha. So di ba ang 1.2 kung na whole number pa na siya, equivalent na siya sa 12, di ba? And then ang probable nga factor sa 12 is 2 times 2 times 3, right? Because 2 times 2 is 4 times 3 is 12. Now, para may mo siyang 1.2, either of this will be in a decimal form. Either of these 3 whole numbers dapat ma-decimal para mahimo na ang 12 into 1.2. So, say pa maagi ani. Let's say if we're going to make 0.3 or 0.2. So, let's say I say 0.3 times 2 times 2. Ang resulta kay 1.2. So, therefore, 1.2 pala. Therefore, 1.2 can be written as the product of the whole number 2 times 2 times 0.3. And then, since 3 raman ang available nato, pwede po na nato ma-express ang 0.3 as a product of 3 times a certain number. Diba? 0.3 is just equal to 3/10. So, diba? 0.3 is just equal to 3/10. So, we can say, in terms of a whole number, 1.2 is equivalent to 2 times 2 times 3 divided by 10. Right? Ang resulting ana is 1.2. Now, applying that one sa ato equation, therefore, we can say that the log of 1.2 is just equal to the log of 2 times 2 times 3 all over 10. Now, applying or expanding this expression, this is equivalent to unsa man? That is log of 2 to the base 10 plus log of 2 to the base 10 kay diba multiplication man. But on the last part, si 3 lang ang i-multiply. So that is plus log of 3 to the base 10. Si 10 gi-divide naman ni 3. So therefore ma-minus na siya. Minus log of 10. Now, take note with this. Unsa ra siya? Diba? Remember sa property nga if we have log of a to the base of a is equals to 1. Diba? Unsa may base are? Diba 10? So therefore, ang log pala of 10 with the base of 10 is also equal to 1. Okay, same man, diba? Kani ma-prove na siya. Kaya kung ato na i-convert, remember, this is convert this into exponential. That is, the resulting number a is equal to the base, sa may base, a raised to the answer, which is our exponent, equal to 1. So therefore, ma-1 ni siya diri nga part. So, kani siya, sorry, ito na erase. So, kana siya, ma-1 na ni. Log of 10, kung bisag imo na ikuan sa calculator, ma-1 gina siya. Ma-1. So, kani siya, therefore, namatay given nga, ang log of 2 daw is equal to x, diba kani? So, i-substitute nimo, log of 2 is x plus log of 2 na pod is x gihapon plus log of 3 kay y man, diba? That is plus 3, plus y minus 1. Or that is equal to, ma-combine ang terms to x plus y minus 1. So, therefore, mao na ang equivalent sa log of 1.2 in terms of x and y. So, mao na siya, class. That is our answer. Now, let's proceed to some applications nga nag-involve siya og kanang logarithmic nga functions. So, here, mostly sa mga applications sa logarithmic class, hatagan din ta og logarithmic nga function. Man ang model nga mo-represent sa ato ang problem. So, as you can see here, ingon siya nga, for selected years from 1980 to 2000, the average salary y, so in thousands niya, $1,000, for public school teachers daw, for the year t, can be modeled by the equation. So, ato isuwat og dako ang equation, that is f of x is equal to negative 39.2 plus 23.64 ln of t, such that the domain of our time here is nag-start siya sa 10, then mo end siya sa 30. So, mamo ni ang domain nato. Remember, for a function na siya domain. Kaya nga atong independent ani nga variable kay t man niya, ang atong dependent kay f of x equals to y. F of t din siya. F of t ni siya. This is f of t. Okay. Then, where t daw is equals to 10 represents 1980. So, therefore, at t is equals to 10 dahi, ang year anak kay 1980. Now, during which year did the average salary for public school teachers reach 40,000? So, again, kani siya nag-represent na sa average nga salary sa atong model. Kana siya represents the time in years or the number of years nga hilabay. So, solution, in order to solve for this, so solution, now, ingon man siya, ang average salary daw, so that is f of t is equals to 40,000. So, dollar. So, f of t is equals to 40 lang. Kay ang y diri kay in thousands of dollar man. So, 40 lang may suwat. Ayun na tong 40,000. Okay. So, i-plug na nato sa to equation and then solve for t. So, that is solve for t. So, in our model, that is f of t is equal to negative 39.2 plus 23.64 ln of t. Now, f of t is 40 man, that is 40 is equal to negative 39.2 plus 23.64 ln of t. So, transposing that on the other side, so ako i-inverse, that is 23.64 ln of t is equals to 40 plus 39.2. Then, pwede po na ito i-over para ma-loan na mahabilin sa pikas. So, we now have ln of t, cancel man siya, is equal to, what na siya i-simplify, ang right side, that is 40 plus 39.2 divide by 23.64. The answer is 660 all over 197. Okay, since this is in a logarithmic form, so imot aton siya i-transform into exponential. Diba, unsa man ang resulting number ani? Kani t. So t is equals to unsa man? Ang base for natural logarithm, ang base kay e. Raised to the answer of the logarithm is the exponent. That is e raised to 660 over 197. Therefore, simplifying, the time di is e raised to 660 over 197. The answer is 28.5, approximately 28.5 mo siya ang time. Now, unsa man daw ang pangita man ani kay ang year. Dili man ang ang year in terms of the date kani siya kay ang number of years man siya. This is 28.5 years. So, saan ito pag-solve? Or ang pag-kuhan po ni class, another way po sa pag-solve aning kani siya is, nasa man? Take, kuhan po, ang lain po nga pag-solve ana is, take exponential on both sides. Or erase po nimo, take e both sides. Manay pagkuhan sa exponential put another method. Anyway, same man gyapon na siya sa kung imo siya i-convert into kuan kay. If we're going to take the exponential of both sides, may mo siya e ma-raise gid na kung say nasa left ma-raise tanan. Same pod sa right, e raised to 660 all over 197. So pwede niyo gamitin class. And then remember class, kani siya unsa pasabutan ni, di ba? If you have a raised to the logarithm of x to the base a, di ba ang answer is just the x kung sa na so dara kani ma-apply ni kay since ang ln ang base niya kay e, so therefore ang kana siya kay mahimo na siya og t by this property. So mas maayod nga imong hinumduman tong mga properties kay ma-apply ninyo especially kung mag-solve ka. So that is just equal to t is equals to e raised to 660 divided by 197. So kani siyang expression is just similar with this kung nag-convert ka. Okay. So ngadto ta sa ato ang final answer. Ang final answer kay the year kani siya pasabot ni siya sa date. So since ang atong domain or ang atong time kay nagsugod sa t, so di ba at t is equals to 10 years, that is the year 1980. How about kung si t kay 28.5? So ingon mo daw kuno kay ang average salary kay 40,000, so ato na ikuan nga magsugod siya at 28. So therefore we can say nga pilay change sa time ani. So 28.5 minus 10, that is 18, right? 18.5. So from 1990 to the unknown, ang gap nila kay 18.5. So kani 18.5 ato na i-add sa 1980, so that is 1980 plus 18.5. Ang resulta kay 1998. So therefore magsugod siya sa year 1998. Ang average salary for public teacher is approximate, mo reach siya og $40,000. Sir, nga dili naman kanang kuan 1999. Actually mulapas naman siya kay di ba? Ang duration ba aning when we say 18.5, that is 18 years and 6 months, di ba? So, inig ka 18th year, unsa man ang year, di ba? 1990. So, around 1990, kay 6 months man. So, inig ka June di ay at 1990, dira na mo reach og $40,000. So, sakop siya sa year nga 1990. Kay kung ay mo answer kay 1999, lahi naman mo exceed na mag 40,000. So, at the year within the year 1990, dira ka maka-attain og $40,000 ang average salary. So, take note sa imong answer gid. Base inyo ni i-round up. Okay? I-analyze gid how naa gid ang problem. Okay, so let's proceed to the next. Here, nata example sa electric circuit. So here, naabot tayo model sa ato ang problem in exponential form. I think from the previous, nakadiscuss mo sa kuan ni sa inyo o kanang kuan ing ani nga problem similar problem. So here we have the equation governing the amount of current I is equals to E over R. So after time t, again, dapat consistent ka sa mga units. So I daw here is in amperes. Ang t na diri is in seconds. In a simple RL, so this is resistor and inductor. Okay? Resistor ni siya and inductor. So L ang gikuanan ni. L ang gi-representan ni. L is in henries. So RL circuit, series inductor. Then ang resistance is in ohms. And then an inductance L is in henries. An electromotive force, ang maning voltahe, ang source ka in volts. So, unsa man ang mga given ini? Ingan siya, if ang E daw is equals to 12 volts, then ang R is equals to 10 ohms, 10 omega, then ang inductance kay 5 Henry, so 5H, how long does it take to obtain the current of 0.5 amperes? So, ang I day nato is equal to 0.5 amperes. Okay, unsa man ang required nini? We are required to solve for the time. So, unknown ang time. So, solution. So, solution. So, sa ato ang given nga model, so we have I is equals to E all over R multiplied by 1 minus E raised to that is negative R or all over L T. Siya. And then since natin mga given, so ato ra i-plug in. So I here is 0.5 is equals to ang E is 12 over the R 10. Then 1 minus E, ang R nato kay negative 10, L is 5, then T. So here, pwede na to itagsatag sa or we can just divide both sides by 12 over 10, then 12 over 10. So simplifying this, ato na simplify daan, that is 0.5 divided by 12 divided by 10, the answer is 5 over 12. So here, this is 5 over 12 equal to, makancel naman eh. So may mo lang 1 minus E raised to negative 10 over 5t, or this is negative 2, right? Then, since negative man si E niya, naman diri ang variable nga t, ako na siya i-transpose on the other side para positive. Kaya po si 5 over 12, ikusa siya ni 1. So, it will become E raised to negative 2t is equal to 1 minus 5 over 12. Simplifying, mahimo na siya og 5 over 12, that is 7 over 12. So this one is 7 over 12, then E raised to negative 2t. So this is exponential class, exponential form. Converting this into logarithmic form, di ba? Sa tayuan, sa logarithm, that is, since this is, naggamit siya og natural number E, so gamit po daw natural logarithm. So that is the ln of the resulting number, saman resulting number, kani siya, di ba? That is the ln of 7 over 12 is equal to the, is equal to the exponent. Sa exponent na to, negative 2t. So that is negative 2t. Divide both sides by negative 2. So now tayo t. Our t now is equal to, that is the ln of 7 divided by 12. Or pwede po na nimo mahimong the ln of 7 minus ln of 12. Same na siya. Divide by negative 2. The answer is 0.27. T here is approximately 0.27 seconds. Mo siya ang time para maka-reach siya og current nga 0.5 amperes. Dili sa pag-solve pod class, you can apply sa other method, di ba? Ang other method is you're going to take natural logarithm on both sides, di ba? Natural log on both sides. Pwede po na siya. So kung mag-take tag log on both sides, that is just the ln of the left, that is e negative 2t, is equal to the ln of the right, that is 7/12. Applying the properties, kanang exponent matapad ari, so that is negative 2t, ln of e is equals to the ln of 7 all over 12. Now remember, sa properties sa natural logarithm, ang ln of e is equal to 1. So that is negative 2t na lang is equals to the ln of 7 all over 12. And I think naka-arrive ta og same nga equation diri So nga na ra class. Either way, pwede ka mo gamit ka sa conversion. So kana siya technique ani is conversion from exponential to logarithmic. Kani siya is nag-take ka og natural logarithm on both sides. Anyways, wala kay gi-change kay gi-apply nimo siya sa both sides of the equation. So again, our final answer here. Final answer is t is equals to, or approximately 0.27 seconds in order to achieve an ampere or a current of 0.5 amperes. Okay, mara na siya class. So, let's try another example. So here, we have a problem about home ownership rates. So, it is stated here that the US Census Bureau published the data in table 3. So, na-din siya table from the original problem niya sa book. I think sa module nila kung ikuha. On home ownership rates, a logarithmic model for the data is given by. So, natay equation. This is a function where R is the home ownership rate and T is in years, the time. Wherein ang T of 0 represents 1900s or during 19,000. 1900s din siya. 1990. Okay. So the first one is we are going to predict R in the year 2015. So in the year 2015, since nag-start man siya sa 1990, so our T is equal to the year 2015 minus 1900. That is equal to pila man? 1900 man, no? 1900. That is equal to 115. So grabe, no? Lapas century, that is 115 years. Okay, use this T to solve for R. So from our model, that is R of T is equal to negative 36.7 plus 23.0 ln of T. Now at T is equal to 115 years. So that is R of 115 is equal to negative 36.7 plus 23.0 then ln of 115. Now kani, how easy ra, plug in na sa calculator, that is negative 36.7 plus 23 times the ln of 115. The answer is 72.43. So ang R is the home ownership rate. So ang rate din nato is 72.43 approximately. Approximately 72.23. Mo siya ang rate by 2015. For letter B, compare the actual home ownership rate in 1950 to the given rate by the model. So for letter B, ang ato na po year ani kay wala po si R, ang year na to ani kay in 1950. So unsa may duration from 1900 to 1950, that is 50 years na. So kani siya, this is in 50 years. T is in 50 years. So again, same ra gyapon, that is R of 50 is equal to, from the model, that is negative 36.7 plus 23.0, the ln of 50. So plug in ra, so negative 36.7 plus 23 multiplied by the ln of 50. The answer is 53.28. Approximately 53.28 mo na siya ang rate sa home ownership. So therefore, mo na siyang actual home ownership rate during the 1950, year 1950. Again, mo na siyang end sa ato ang discussion for kanang logarithm. So again, please practice solve logarithmic equations and also logarithmic functions on how to condense and expand logarithmic expressions, and also of course solving for logarithmic and exponential functions simultaneously, and even how kanang practice on how to convert logarithmic expression or logarithmic equation into exponential equation per class. Okay, so thank you for listening and have a nice day.